might also see heat. Right. So this is going to be H2. Right. So we can do a hydrolysis on all these carboxylic acid derivatives to generate decarboxylic acid. Right. I think you already kind of knew this, right? So it turns out that when we do reactions on these guys, they're going to undergo a substitution reaction. And that substitution reaction can either occur in acidic or basic condition. And just give you the basic reaction pattern really fast. And we'll just say this is going to be for basic condition. So we start off with some kind of carboxylic acid derivative, and we reacted with some nucleophile, right? The nucleophile is going to go here, the electron swings up, it's going to be in equilibrium. We form the tetrahedral intermediate. Right, then this electron comes back and kicks off this end that was here. So then we generate our product, which is going to be this. Right, so this is in basic conditions. In acidic condition, the mechanism is a lot longer because of the protonation and deprotonation. But this is the general reaction mechanism, and all you really have to focus on is the fact that this Y right here is going to substitute whatever is going to be here, right? Alright, so we want to make a lot of relationships out of these guys. Alright. Alright, so generally, if you start here, you can make everything downstream, apart from this guy, which is kind of weird. This guy's kind of weird. He doesn't really have like a carbonyl group on it. So generally, you can't move backwards, right? Because generally, you can't move backwards. Generally. Okay. Generally, you're going to be moving downstream, not upstream, because these guys are more reactive and they create the less reactive compounds, not the less reactive creating the more reactive. Cool. So now, if we started from here, right, we can create an anhydride by just dropping in this. So if we drop this in, we can create the anhydride, because this group right here is just going to substitute this group here, and we would create this. Alright? And this one is just hydrolysis, right? We can do that with H2O. Alright? What do you think we would have to drop in to create the ester? That's right. So we can just put in ROH. So it would be ROH and pyridine. The reason why you have to use pyridine is because of the fact that you create HCl in the course of the reaction. And the pyridine helps. So it's like a base. soaks up the acid. Then how about from, what if we wanted to generate this guy? So anything you're trying to generate, this is the nucleophile you drop in.
So it would be that and like H3O plus, or just that?
So it would just be like NH3, depending on what you have here. It can be an R group, right? CH3. So depending on whatever you have there, just add an H on there. Pyridine. Cool. If we started with this, the anhydride, we can generate this guy by hydrolysis, right? And from here we can generate the ester. What do you think we would have to drop in?
R group as an example.
Whatever this is. So notice how the reaction mechanism occurs, right? That's right. So just by looking at the product, whatever is here, just add an H to it, and you can figure out what the nucleophile needs to be that will substitute this group here.
Okay.
ROH is fine. And this time we don't use pyridine because we're not creating an acid. Well, kind of. We are creating carboxylic acid, but it's not really all that acidic. Alright, how about from here to here?
Maybe the NH3.
Yep. And also, there's, oh, that's about it. Now notice that from here, we can't go back here. Alright. Now notice though, if you wanted to go from here to here, okay, we haven't gotten the reaction yet, but there's a way. So we started from this carboxylic acid. Well, I think we did kind of this. We kind of talked about it a little bit here, right? This reaction here, SOCl2. You take us here, right? Now, if we start off here, we can get back here using what?
The
SOCl2 or PCl5. Right. Now, notice that if we started off with this anhydride, we wanted to generate this acid chloride, we couldn't go here directly. We would have to hydrolyze this guy into the carboxylic acid. Then from here, we can just take this route and go back here. All right. Then from here, we can make everything else downstream. Right. If I had this ester and I wanted to generate this guy here, I would have to hydrolyze this guy to the carboxylic acid, and from here go back here.
Alright.
Cool. Alright, so from here we can generate the acid chloride. This one is an exception because it's going backwards, right? And also there's another reaction you can do on here, or you can get here. Right? And it's this reaction again, P2O5. You remember this reaction? So this is, you can form an anhydride with 2 carboxylic acids using P2O5. Right?
Okay.
Do you remember Fischer esterification?
I remember learning.